Yes. Woo! All right. Oops. Okay. Gonna be out of here soon. Hello, hello. Okay, we got a couple more. We got to have a couple minutes. For those who have chimed in, I am monitoring the chat. Double check camera. Camera check looks good. Sound, audio. How does that sound? Hello. How does the does the audio quality looks good? Video quality looks good. Okay, seems to be working fine. Okay. Where can you find labs 3 and 4? Lab 3 and 4 on Canvas. I can't post lab 3 publicly because it has a real target. I can't post lab 3 public. I will need to post lab 4 publicly. Yeah, that I need to do. Has to be on Canvas. Thanks for reminding me about the labs. Yeah, I need to make public. 4 can go public, but not 3. 4 can go public. I need to put that on the website, but definitely not. Definitely not 3, because we're going to use a real target for that one. And basically today, after today's session, you should be able to do lab 3. You should be able to do lab 3 as soon as possible, and I strongly recommend everyone to do lab 3 as soon as possible, because you know what happened with college kids. Everyone wait till the last minute, and if too many people are hitting the server, we're going to have problems. So after today's session, I would definitely say do the 3rd lab as soon as possible. It's on Canvas only. It is not made publicly available because it uses a real target or targets. All right, hello everyone. Hello. So now it is 4:30. 4:30 Eastern time here on the East Coast. Hopefully everyone is staying safe. Yeah, weather's not good outside. I want to start off immediately by saying congratulations to the NASA Perseverance team. They landed the rover on Mars. I want to say congratulations. Looking forward, it looked like a very bright future. And if you want me to say some humorous comment, okay, we now look forward to seeing. We look forward to finding Elvis, and Marvin. Yes. But no, seriously, congratulations to the NASA Perseverance team. Yeah, congratulations. So last week on Twitch, we did packet analysis using Wireshark. So last week we used Wireshark. So you may be wondering, will we be using Wireshark again? And the answer is absolutely yes. Last week was about basic networks, was about, analyzing network traffic. But today this is where the things get really interesting. Today is going to be a start of attacking networks. Yep. Today we're going to do one of my absolute favorite topics. Is going to be on network reconnaissance. You may actually, for some people on the technical realm, may actually look at it as scanning. Okay, network scanning. So today my desktop has changed. My desktop picture has changed. And my desktop picture has everything to do with today's live session. Here on my desktop, the picture that you see is a number of different circles. Notice the blue. So you see at the very left, you see recon or reconnaissance. Then you see weaponize, then you see deliver, then you see exploit, then you see install, command, and act. This process, recon, weaponize, deliver, exploit, install, command, and act, is better known as the cyber kill chain. In plain English, what the cyber kill chain is the process on how to go and you're given a target. It's the entire process of finding everything that you know about the target, act on it, and then do your whatever you want in terms of malicious activities to that target. This process is better known as a cyber kill chain. I repeat, this entire process is better known as a cyber kill chain. And I finally found a website today on which illustrates this whole process of the cyber kill chain. This process was originated by Lockheed Martin. And Lockheed Martin came up with this. It's a framework model for identification and prevention. It's for identification and prevention of cyber intrusion activity or activities. The model identifies what the adversaries, the attackers, must complete in order to achieve their objective. So if you actually take a look at this entire model, I call it the cradle to grave model. The entire process from start to finish for an adversary to go and take over a target. Today our focus is going to be on reconnaissance, or in plain English, information gathering. Okay? And so here it is. Reconnaissance includes like harvesting email, conference information, etc. Later on in this course, we'll do weaponization, and exploitation. We're not going to do that today. But today's point is going to be, the whole gist of today is going to be reconnaissance. Finding everything that you want to know about a particular target. And today, we are going to actually work with a target. And the target is going to be at the IP address 192. So I'm going to clear the screen here. And the target, I'm going to make a note to everyone. It's going to be 192.168.1.241. Now, chances are this is not going to work on your, this won't work on your infrastructure or your environment. So this target at 192.168.1.241 is running on my network at home. It is a virtual machine. It is a VM. Okay, so on that note, which is very important to know, so on the very first session, the very first live session I did 2 weeks ago was on virtual machines. And now we're going to see why I started off this entire course and ultimately the live session on talking about virtual machines. Because virtual machines, or running virtual machines, whether it is on your own computer, whether it's on your home network, whether it's in the cloud, is a great way to set up live targets that you can practice on, and that you can practice on legally. So that's the important value of using virtual machines. So setting up using virtual machine will give you a nice legal environment that you can practice or hone your cybersecurity skills on. And I have a target running on 192.168.1.241. What kind of a target is this? What kind of virtual machine is this? I'll talk about that later on today, okay? And where you can actually download it for your own practice goods. But the target that we're going to be working with today is at 192.168.1.241. This is on my home network. So if I just echo it out, so it's going to be 192.168.1.241. What in the world is this thing? What in the world is this target? Okay, there's a lot of questions that you can ask about this target. What is it? What other questions can we ask about the target? What kind of software is it running? What ports are open? What services are open? Where is it geographically? That's another one. And also another one I can think of is it up or down? Is it dead or alive? Is it actually a live running target? So let's start off with that first. Okay, our job today, what we want to do is given a target, given a computer that we want to exploit, we want to know everything about this before we start breaking into it. Okay, so this is a target we want to do all the dirty, sinful business on. But before we do any attacking or any exploitation or any, before we launch any attack, we want to get as much information as possible about this target. So the first thing is, at the very most rudimentary level, is let's ask the question, is this target up and running? And the way we want to check if this target is up and running or not, a very basic way is to use a tool called ping, P-I-N-G, man ping. What ping does is it's quote-unquote sends ICMP echo requests to network hosts, okay? And the description says, a technical description is yada 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 yada. Okay, so it sends arbitrary port to whatever. Okay, so what ping works, how ping works is this. It sends an echo to a network host or a system, and you hope that you will receive a reply. So ping is a very simple protocol. Okay, think of how submarines and sonars work. If they want to see if there is an object ahead, they would send a ping signal. You send a ping wave, and if it hits something, there will be a response. That will be pong. Okay, ping is commonly used for diagnostics. It's for diagnostic purposes to see if a computer or something on the network is up and running or not. That's all it does. Okay, so ping is a very simple protocol. So if I do ping 192.168.1.241, I get a whole bunch. Okay, so 64 bytes ICMC sequence. Okay, so all right. I'm getting 64 bytes from 192.168.1.241. Okay, so we're receiving data back. We're receiving responses back from the target 192.168.1.241. I hit Control C to stop receiving data back from 192.168.1.241. 16 packets transmitted, 16 received, no packet loss at the time of 15,000 milliseconds. This is pretty good. That means we're getting stuff back from the target. This computer that is at 192.168.1.241 is sending back responses. In other words, in plain English, what that means is this computer running at 192.168.1.241 is up and running. It's alive. It is alive. It is a live computer, not dead. However, if I do ping 192.168.1.243, let's say some other IP address. No, it's a stream meant for students. It's meant for the whole world. Now, if you actually do a ping, no, please stay. Please stay. It's anyone who wants to watch. Anyone who wants to watch. Now, here's the problem. On going back to this example, if I do a ping at 192.168.1.243, we're gonna get stuff saying that destination host was unreachable. This is not good. If I do a Control C out of the terminal now, it says 26 packets transmitted, 0 received, 21 errors, 100% packet loss. This is not good. That means there is no computer at 192. There is no computer running at 192.168.1.243 on my home network. This is gone. But of course, if I do 241 again, okay, 241 again, it's working. And I hit Control C. All right, so one thing that we know already from our basic reconnaissance and information gathering technique is this. The target computer at 192.168.1.241 is up and running. So this is a live computer. It's working. Okay? It's working. This is good. Here's the problem with ping, though. Ping doesn't tell you anything else other than if a computer is dead or alive. I repeat, ping doesn't give you back any other information other than a computer is dead or alive. What ping doesn't provide is it doesn't provide anything else about a remote computer or a target. You're not going to see information such as port numbers. You're not going to see information such as software version. You're not going to see operating system version. You're not going to see even possible vulnerabilities at all. Ping doesn't give you much information back other than if a computer is up or down. Okay? What's the difference between .241 here and 243? Are they just working or not? That's it. Okay, that's the difference between .241 and .243. All we are just doing right now is if they're working or not. .241 is working. .243 is not working. We don't care about that one. Our focus is going to be on the .241. Okay? Our focus today is going to be on the .241. So that's a good question. All right. Is there any other information we can get with ping? Not really. No. There's not really. But ping is really good for simple diagnostic tools. It's really fast, too. All right. So if ping, it doesn't only give you this set of information back, what else can we use? I'm going to clear the screen now. There is another tool that we can now look forward to. Oh, you can get latency from ping too. Like, you can get some detail. You can infer details of, latency and performance. All right. So what's the next step up? The next step up is I want to introduce to you one of my favorite tools because it's really called the Swiss Army knife of networking, and it's called Netcat. And I have this cheat sheet here. I think I can post this on the Twitch stream. I have a cheat sheet here. If you ping it and it's dead, should you stop right there? If you say the host is unreachable, not really. It's a bad sign if you can't ping a computer, but you shouldn't stop right away. You shouldn't stop. And that's a really good question. If you ping something and it's dead, should you stop right away? I say no. Don't stop right away. And here's the reason why. It's a really good question because there's a lot of computers and servers and routers out there that turn off ping. They won't even respond to ping at all. For a reason we will talk about next week. Because it is an abused protocol for distributed denial of service. It's a really, really good question. If a computer is dead, if you ping it and it's dead, don't stop right there. Again, the reason being is that a lot of systems now turn off ping. I know there's an option. If you have a Mac computer and you go to the firewall, I'll show you. Let me see if I can. In my system preferences, I think it's under security, and you go to the firewall tab, and there should be an option under advanced. There should be. Okay, let me try this. Let me show you. No. Let me see if I turn on the firewall. If I turn it on, I should be presented with an option that said, I don't want to turn it on. I don't want to turn on the firewall at all. Well, there's a firewall option that says you can deny ping. You can actually turn off ping. So I wouldn't just stop here. No, don't do it. Don't do it. It's a good question. All right, let's go back to Netcat. So what Netcat is called the Swiss Army knife of networking. Netcat you can do a lot of different stuff with. Netcat, you can use it to serve files, download files, make arbitrary network connections. At the main fundamental level, how Netcat works is Netcat, target IP, port address. Yeah. Netcat, target IP, port address. And then you hope that something comes back to you. That all you do when you do Netcat, target IP address and port number, you just you just connect to an arbitrary port number at IP address at the IP address. Okay, so what I can do here is let's go back to Kali. So Netcat is NC on Kali. Netcat is a simple Unix utility to read and write across the network connection using TCP or UDP. Sure, yeah. So it's a simple usage, and Netcat host port create a TCP connection to a given port on the given target host. And it will try to do what they call the three-way handshake. So if I do Netcat 192.168.1.241, let's put a port number. Let's say 80. Uh-oh. I'm going to hit enter. Cool. I got something back. Netcat 192.168.1.241. Let's try another arbitrary port number. Let's pull something out of a hat, like 28. I don't think this is going to do anything. I'm just pulling a number, some weird number. Cool. Netcat at 192.168.1.241 at port 28, connection refused. Alright, let's go 29. Connection refused. 30. Connection refused. 31. Connection refused. So it's almost like I'm just doing that crank call of a phone number game. You know, I can just go on here and just type in every single port number from 10 to 660,000. I can do that. What are the different port numbers from an IP address? An IP address, you know, can offer many different services. Let's say, for example, if an IP address offers a web server, you'll probably see port 80 being open. If you see if an IP address offers it's an SSH server, secure shell server, it'll have port 22. If an IP address offers port 21, that means it's going to be an FTP, a file transfer protocol server open. Here, I'm going to try 21. FTP. Ooh, 220 VS FTPD. 234. A computer can offer many different types of servers. A computer can offer, let's say, web browser, a web server, email server, like Hillary Clinton's email server, a database server, and it can offer like a whole bunch of different. It will open up a whole different port numbers. Most computers in the world, you know, if you're not going to be offering anything to the world, you're not going to have any port numbers open. But some computers, like a video game server, my favorite port number, I hit Control C, is 666. Port number 666, anyone know what that is? In this case, this computer at 192.168.1.241.666, connection refused. 25565 is Minecraft, yes, okay. 666 is Doom, as in old school Doom. John Carmack and John Romero Doom. Okay, so different IP addresses can offer, usually can offer different expose different port numbers. And each of those port numbers means something. If I ping the FTP port and all right. Here's the question: If I ping the FTP port and it responds, does it mean that I can actually transfer the file between the two computers on a terminal? Okay. So we have to be very careful. But you bring up something extremely important. The first part of your sentence is extremely important because you got it wrong. And this is a really good trick question I ask all the time on quizzes. It's also a very common cybersecurity interview question. If I ping the FTP port, here's the thing. You can't ping a port. I repeat, you cannot ping a port. Here's why. IP address, when the ping only uses is only on layer 3 of the OSI model. Ping only use IP address and that's it. Ping has no idea of the concept of port numbers, which is on layer 4. But it's a very good question I want to you brought up, and I'm happy that you brought it up. I'll show you. I'm going to introduce you to Dan Meisler. Cyber security. I think I spelled his name wrong. I-E. I'll show you. 60 cybersecurity interview questions. I use this all the time. I'm going to paste this link. And there is a great question under network security. What port does ping work over? A trick question to be sure, but an important one. If they start throwing out port numbers, you may want to immediately move to the next candidate. Hint, ICMP, also known as ping, is a layer 3 protocol. Layer 3 on the OSI model. It doesn't work over a port. A good variation of this question is to ask whether ping uses TCP or UDP. An answer of either is a fail, as those are layer 4 protocols. So here's a good reason why you really need to know about the OSI model. Okay, but it's a really good question to ask. You can't ping a port. However, if I change your statement a little bit, to if you actually netcat the FTP port. So if you like K Doggos, if you netcat the FTP port and it responds, does it actually mean I can actually transfer files between the two computers on terminal? And the answer is, generally speaking, yes. That is a generally speaking yes. So I'll go back. The FTP port at port 20. Now you're seeing VSFTPD. You're seeing this right here. It means, yeah, that means the computer at 192.168.1.241 offers a file transfer protocol. That means you can transfer a file from this computer, the Kali computer that I'm on, which is at a very different IP address. What is my IP on this thing anyway? At IPA. You can transfer a file between 192.168.1.249 to 192.168.1.241 at port 21, the FTP. Yeah, you still probably need to, maybe, or maybe not. Maybe the FTP server allows anonymous stuff. All right. So is there a shortcut, though, in Netcat where I can actually, instead of just entering every single port number, that I can actually just run like a loop or something and try every single port number from like 10 to 6,000? And the answer is yes. On this cheat sheet on SANS, which I posted on this chat, there is a TCP port scanner cheat sheet option here. Is netcat -v -n -z -w1 provide the target IP address, space, and then of course you have the starting port number and an ending port number. And the explanation of this entire command on Netcat is attempt to connect to each port in a range from end port to start port on IP address, target IP address, running verbosely, which is a -V option on Linux, -VV on Windows, not resolving domain name without sending any data, and waiting no more than 1 second for a connection to occur, which is a -1 flag. Oh, interesting. So what happens if I do netcat minus, okay, actually I had it pre-ordered, -V, -N, -Z, -W1, all separated by a space, IP address at 192.168.1.241, and I'm going to give a start port at 10 to end port at 1000. I don't want to do all 60,000 yet. Let's try this. You ready? If I hit enter, what happens is, bing! Interesting. Port F21 FTP is open. Port 22 SSH is open. 23 is open. 25 is open. 53 at domain server is open. 80 is open. Not bad. Let me change it to 10,000. Let's see what happens. If I do the end port number to 10,000. Bam. Woo! So here on Netcat, okay, here on Netcat, you can see the target IP address that we're working on, 192.168.1.241. You can see the port numbers open, and then you can see inside parentheses the name of the protocol or the service that's being open. MySQL is a database. PostgreSQL is a database. 445 is interesting. SMTP, port 25, SMTP email is open. Can't you get into legal troubles with port scanning? Yeah, I mean, you can. Again, we're practicing on a legal domain, we're practicing right now on a virtual machine. But here's a problem though, on the legal issue thing. Can't you get into trouble with legal trouble with port scanning? The thing is, everyone does it. Everyone does it. Like every network operator like sees scanning traffic all the time. Can you actually catch the bad guy? It's too expensive. I mean, people are scanning computers all the time. To catch someone is too expensive. Way too expensive in terms of money and, God forbid, time. X11 is a port? Yeah, it is. What makes a VM differently in terms of legality? Okay, what makes a virtual machine different in terms of legality? A virtual machine actually is usually run on your own environment, on your own system, so it doesn't affect other people. Port 6000, I have no idea. Yeah, there it is, X11. There's an X11 server on here. Okay, so there's a legal issue, yeah, but then again, everyone scans the internet anyway. Are these tools legal? Again, I said this, I think, a couple of weeks ago, that any security tool can be used for both good and bad. System administrators scan networks, like, for example, if you're on, like, say, an enterprise network or a school network like Tufts, administrators use port scanning all the time because we want to see, for example, a very good example is you want to see if anyone is running like a web server or, God forbid, like a BitTorrent server or God forbid, an email server, because those things are usually riddled with vulnerabilities. Yeah, one of our reading companies get upset about scanning. The one about, yeah, So again, everything goes both ways. Some people get really angry at it, but if you're a system operator and you're seeing network traffic, people scan stuff all the time. Wait until you spin up a virtual machine on the cloud. The moment that you actually open up a virtual machine on the cloud, like, people are just going to hit it immediately. Yeah. So going back here, here's the problem with using Netcat. Netcat's behavior on different systems is very inconsistent. It's very inconsistent. On Kali Linux, the cheat sheet command for a TCP port scanner works well. It's not the case when you actually try to do it on a Mac. Mac has their own version of Netcat installed. Like Ubuntu has a different version, has a version of Netcat installed, but you got version differences and all that stuff. Yeah, you got bots too. Didn't mention that. Um, Netcat is a really, really powerful tool to make arbitrary connection, but for port scanning, the behavior can be pretty erratic and inconsistent. If you try to do the command that we just did on another variation of Netcat or another version of Netcat, you may not even get the same results. Okay? So that's a big problem with using Netcat for port scanning. The other big thing about Netcat, about using Netcat, is you can't get into very specific details about what exactly version of PostgreSQL or MySQL or SSH or the HTTP server the target is running. So we want to do something like operating system detection as well too, more complicated things. So now it is my pleasure to introduce to all of you one of the most quintessential tools in cybersecurity, and by far and away the most famous port scanner in the world, better known as the Network Mapper. The Network Mapper, also known as Nmap. The very famous Nmap, which was written by my friend Fyodor. So I want to introduce you to Nmap. Nmap is a network mapper, nmap.org. Okay? What is the goal of network scanning? Reconnaissance. Looking for people who are on your network, specific malicious threats. Yep, all of that. More importantly, you want to see what services the computer is being offered, what if the target is running any vulnerable software, if it is having if it allows password authentication for anything. Okay? So that's the goal of network scanning, to gather as much information you can about the target. And yeah, that also includes vulnerable versions of software that's being used. Um, you know, uh, Network Mapper, here it is. So Nmap was written by Fyodor, free and open source. Many system administrators use it to find network. Here it is, for network inventory, managing service upgrade, you name it. Nmap uses raw IP packets in novel ways to determine what hosts are available on a network, what services are those hosts offering, what operating systems that are used. So this is answering your question. What type of packet filters are being used, and dozens of other characteristics. So using Nmap, you can also see all the computers and every single computer that is hooked up to your network. So I do this at home all the time. You know, um, if you run Nmap against, you know, um, against your router, you can see everything that's hooked up to your network, like the light bulb, your coffee maker, your Xbox, video game console, you name it. Okay. So Nmap has a lot of, it's well documented. Um, Tons and tons of different options. But also, just on a fun note, is that Nmap has also been in many movies. Starting off with here it is, movies featuring the Nmap scanner. For some reasons unknown, Hollywood has decided that Nmap is a tool to show whatever hacking scenes are needed. Nmap was used in The Matrix Reloaded. When Trinity was trying to, I think it was one of the scenes where she had to break into the power, I think it was a power plant or something. Nmap was used in Ocean 8. She used Nmap to compromise. She uses Nmap in many scenes to compromise people and companies responsible for guarding the $150 million diamond necklace that they wanted to steal. Nmap is normally shown in the background. Nmap was also used in Snowden. Judge Dredd, Asylum, Apparently it was even used in Fantastic Four. Well, Die Hard 4, it was even used. So it's funny that you had to bring up that. Can you also use these tools to systematically determine which ports were allowed to? Yeah. Oh, yeah. Mm-hmm. G.I. Joe Retaliation. Huh. They seem to send a scan. They seem to scan a missile silo with Nmap SSH to each ICMT SU to each SU to each route and then execute it. I'll just paste this here. I'll just paste the link. So yeah, I mean that's how like there's many movies that have used Nmap, and also if you can take a look at them, I mean you take a look at it, it really will answer the question like why, what's the goal of network scanning? Like it really does, like tell you what the goal of network scanning is. So I want to go back to this example, go back to the terminal, and let's actually use Nmap. Nmap, the manual. Nmap is for network exploration tool and security / port scanner. So Nmap can not only determine what's on your network, but also it can do things like port scanning and even determine some security vulnerabilities. There's a lot, and I mean a lot, of different options in Nmap. Like it's a pretty deep tool. At the very most rudimentary level, Nmap is pretty simple to use. It's Nmap, and then just type the IP address of the target or the computer or the network that you want to use. So I'm going to clear Nmap 192.168.1.241. I'm going to hit enter. Boom. Nmap can be pretty quick on a local network. But you can do all you need to do at the very most rudimentary level is Nmap followed by the IP address. That's it, of your target. In this case, it's 192.168.1.241. So here it is, starting Nmap, and here's the report. And here's the host that says the host is up. So it does a ping for you. Not shown. 977 closed ports. And you can see a listing of all the ports that are open on the target and the corresponding service name and the state. So it seemed like this target has a lot of different services open. Lots of services open. Database, email, web server, Telnet, SSH, FTP, you name it. So now I get this list. Of everything that is open on the server. Oh, this is a port 66667. There's an IRC chat server open. Pretty cool. All right. So what I can do next is the following. Now I can see all the list of services and port numbers that are open on this target. I think I forgot who it was that mentioned on this. Let's see if I do FTP 192.168.1.241. If I do an FTP, blah, password, whatever, login failed. Well, I can try to brute force the system if I want. Okay. So if I try to go on a web browser and I go 192.168.1.241, because I see port 80 open, because this target says, on the Nmap report, at 192, here it is, port 80 is open, HTTP. So can I do HTTP on a web browser, 192.168.1.241? And the answer is, bingo. There's a web server running. Warning, never expose this VM to an untrusted network. Contact MSFdev at Metasploit.com. Log in with MSFadmin/MSFadmin to get started. And you can see a whole bunch of things. We can see a whole bunch of things on this website. This is a target that we're analyzing. All right. So Nmap is just a tool. It's a real powerful network tool. I mean, you can even do, if you want to search for a range, you can do Nmap 192.168.1.1, and let's say you want all the IP addresses on your network, all the IP addresses. You can do something. I'm not going to hit enter because it could take a while. Okay, you can even do this like /24 notation to get all the IP addresses here. How does Nmap work? How does Nmap work? Yeah, I'll talk about Metasploit a little bit later today. But Metasploit is one of the famous tools in cybersecurity which has everything for you. What is Metasploit? The Metasploit project by Rapid7. I want to give a shout out to Rapid7. Metasploit project provides information about security vulnerabilities and aid penetration testing. Shown by Metasploit by Rapid7. Metasploit.com. It is like your one environment that you can do everything: scanning, sniffing, exploitation, you name it. Do security assessments, you name it. So, moving back though, how does Nmap work? Well, let's go refer to the document. I'll post this on Twitch. How does Nmap work? Port scanning techniques. Okay, one of the things is if you just don't know how the tools work under the hood, then you're just a script kiddie. And it says that in the first article, in the first paragraph here on the Nmap document. As a novice, I struggle for hours trying to fit my rudimentary tools to the tools at hand. When I fail miserably and tow my jalopy to a real mechanic, he invariably fishes around in a huge tool chest until pulling out the perfect gizmo, which makes the job seem effortless. This is important for anyone who's studying cybersecurity. The art of port scanning is similar. Experts understand dozens of scan techniques and choose the appropriate one for a given task. Inexperienced users and script kiddies, on the other hand, try to solve every problem with the default sync scan. Since Nmap is free, the only barrier to port scanning is mastery of knowledge. That certainly beats the automotive world, where it may take great skill to determine that you need a stretch spring compressor, then you have to pay thousands of dollars for it. Okay, so how does Nmap work under the hood? By default, how Nmap works is the sync scan, TCP sync scan. Recall the importance, and this is why it's important to know about the TCP handshake, sync, ACK, and ACK. The sync scan is the default and the most popular scan option for good reasons. It can be performed quickly, scan thousands of ports per second on a fast network not hampered by restrictive firewalls. It is also relatively stealthy since it never completes the TCP connection. I repeat, it never completes TCP connection, so there's no sync ACK and there's no ACK. Sync scan works against any compliant TCP stack, depending on the idiosyncrasies. Okay, this technique is often referred to as a half-open scanning because you don't open a full TCP connection. You just send a sync packet and that's it. As you're going to open a real connection and then wait for a response. Sync ACK and then, okay. Here it is, a sync ACK. Here it is. A sync ACK indicates the port is listening, open, while a reset RST is indicative of a non-listener. Get out of here. Okay, do we have class on Wednesdays? The answer is no. Only for the online master's program. Okay, so by default is a sync scan. There's also a whole bunch of other scan options that there are. I'm going to stop here. So now, wait a minute. Let's go back and do the Nmap scan again. We got our results. Now, one of the things I said that Nmap can do, which can't be done on Netcat, is what happens if you want to get more deeper information? What happens if we want to know what operating system the target is running? What about the specific software versions of HTTP or Postgres or VNC that this target is running on their respective port numbers? Well, one of the things that Nmap can do is to enable something that has stuff such as operating system detection. It's a -A flag. Enables operating system detection, version detection, script scanning, and trace route. Just a -A flag. Okay? So I'm also going to actually introduce you to the -P flag. The -P flag, there's a -O for enable operating system detection. So say, oh, maybe this is a Windows, maybe this is Mac OS, maybe this is Linux. The -P, -P0, right? P and an N is the number. Treat all hosts as online, skip host discovery. Okay? So if I clear the screen now, and let's do Nmap -A -P0. So no host discovery, no second, just go. 192.168.1.241. Let's see, do that. So this time we're going to add two flags on there. One is for operating system and software detection. The other one is going to actually move fast. No host detection at all. It's going to take a few seconds. All addresses will be marked as up and scan times will be slower. So this is going to take some time. It's going to take some time. It's not instantaneous because it's going to take some time to do operating system and software version detection. You get anything? Yeah, I mean, you're going to have to do elevator music. But while we're doing this, while we're waiting on this, can anyone actually think about is this running on a local computer or is it making API? Local computer, no API call. No API call at all. Straight local computer. Nmap was written in C. So it should be, oh, boom. Holy shit. Service detection detection performed. Please report any inaccurate, incorrect results at Nmap. Okay, so it's a big report that we just got back. Huge report that we got back. So this time, we not only get the port number, the service, and the state, but we also get the software version. Interesting. So here is the result of the Nmap scan with software version detection. Interesting. Does anyone notice anything? Well, here you go. Port 21 is running VSFTPD at 2.3.4. What is the latest version of VSFTPD right now? VSFTPD, latest version. Let's go to Wikipedia. It's 3.0.3. Here's VSFTP. VSFTPD is probably the most secure and fastest FTP server for Unix-like systems. Last released in July of 2015, 3.0.3. So, yeah, 2.3.4 is a very, very old version. You would probably bet that this FTP server is really old and it's probably riddled with vulnerabilities. And if FTP is anonymous, that's another problem. And now this is why you want to do operating system and software detection. You can see in this example it says anonymous FTP login allowed. Yep. So that means we can transfer files from this Kali machine to the FTP server at 192.168.1.241 using using an anonymous login. Can you believe that? Here you go. Connected to logged in as FTP, no bandwidth session timeout, control connections in plain text, data connection will be viewed in plain text. This has an SSH server at OpenSSH version 4.7. Linux Telnet D is open. Postfix. I don't know what that is. 53. Port for the ISC bind at 9 point. Okay. Here it is. Here's a good one. HTTP server is running Apache HTTPD 2.2.8. Holy crap. What's the latest version of Apache right now? Latest version of Apache is 2.4.46. So you can probably say 2.2.8 is really old, probably riddled with a lot of vulnerabilities. Okay? You can see the header information. You can see Samba's open. You can see a root shell at 1524. What? Really? You see an old version of MySQL running, an old version of Postgres running. Postgres like up to 10 right now, at least. VNC is open. Metasploit. Wow. Lots of stuff. Unreal Tournament. IRC is open. 6667. 6667. Unreal Tournament IRC is open on this thing. Tomcat server. Here it is. You can probably figure out from without even doing operating system level detection, this is probably a Linux computer. You're seeing Linux all over the place. Okay. Samba is open for file sharing. Lots of information. All right. Lots and lots of information. Just read all this information if you read all this. So now, given all this detail on software version and operating system version, you can now infer, okay, all the old software that this virtual machine is running, and you're probably having a ton of vulnerabilities. The one I want to find that's interesting is 1524, Metasploitable root shell. What in the world is that? So I want to actually clear the screen. Now, so root shell, what happens if I do 192.168.1.241 at port 1541? It said 1541 is open, so I just netcat into it. Guess what happens? What? 192.168.1.241. 1541 is connection refused. Are you kidding me? That was the one that was open, right? I thought it was. Do it again. All right. How loud, this is a great question, which translates into the next one. How loud is this kind of scan? What would the target be able to see? Well, that's $1 million. Please, ToadReal, please give yourself. Yeah, so I'm happy. I want to, okay, if I had to give a gold star or anything on Twitch to anyone, ToadReal asked the $1 million question of the next day, of the day. How loud is this kind of scan? What would the target be able to see? The target will be able to see quite a lot if the target is recording packets. So the problem is, it's a loud kind of scan. I mean, once this is happening, the target will be able to see, okay, a computer at whatever this IP address is doing something. It's doing a lot of activities trying to do a port scan of this machine. So it is loud. It is loud. And the reason why I'm happy that you brought this up is, the next thing I want to talk about is there a way that we can make this not so loud? I thought 1541 was open. Oh, 1524. My bad. That's my bad. 1524. This is why the details matter. 1524 bind shell. Can Wireshark pick up these scans? Oh yeah, they can pick up a lot of stuff. I'll show you one of that in a bit. Here it is. It's like and that's a perfect analogy from Oblivioner. It's like knocking on someone's door. Alright, so, Gabman, 15. I'm curious how vulnerable that root shell is. Well, here you go, let's do that. Netcat at 192.168.1.241. Can you see? Netcat at 192.168.1.241. Port 1524. I'm going to hit enter. Boom. Got in. That's a root shell. LS bin. LS home. CD home. LS. You got FTP. CD MSF admin. LS LR. Well, yeah. Root shell is root shell, my friend. You have root access. Can I do RM minus RF? Yeah, I'll do that at the end of today. Exit. If I hit exit, I'm out. Yeah, I mean, there it is again. I mean, it says there was a root shell that was open here at 1520, port 1524, bind shell, metasploitable root shell. It's still up. Bam, still open. Exit. All right, so let's talk about the whole idea of loudness and stealthiness. Here's the thing about Nmap. Nmap can get pretty noisy if you use those type of scans. But is there a way that we can actually do not so noisy scans? And the answer is yes, absolutely. Take a look at the manual again. What was the last command I did with root again? You mean the Netcat one? That one? Netcat, space, target IP address, space, the port number, which was 1524, which we found from the Nmap results. I want to talk about, I want to now go and speak of doggos. No, not doggos. Gabman. No, not Gabman. Who was it that actually mentioned? What part of the Nmap results actually showed you 15? Yeah, it was just part of the Nmap results. Go back all the way up. Do it again. What part of the Nmap result told you 15.4.24 is open? Look at the results again. Look at the results again. Look at the results again. Watch. Takes a few seconds. While that is going, still going to take a few seconds. Can you catch the result somewhere? Yeah, I didn't think of it, but all right. So here's the issue about how loud a toll drill said. How loud is this type of scan? Here's an alternative, although it's not perfect. You can get even a little bit stealthier, which are called TCP null, fin, and Christmas tree scans. And the manual says the following. I'm going to enlarge the text here. Here it is. These three types of scans, TCP null, TCP fin, TCP Xmas scans, exploit a subtle loophole in the TCP RFC, request for comments, to differentiate between open and closed ports. Page 65 of the RFC 793 say that if the destination port state is closed, an incoming segment not containing a RST flag causes an RST to be sent in response. Then the next page discusses packets sent to the open ports without the same RST or ACK bits, is saying that you are unlikely to get here, but if you do, drop the segment and return. So the point being is, when scanning system compliant with this RFC text, which is a lot of system, any packet not containing sync, RST, or ACK bits will result in a return RST if the port is closed. If you're scanning a system and the port is closed, it's going to send you, hey, target, do you port 23 open? And the target will, if the target was going to say no, okay, no, get out of here. I'm going to send you an RST flag. If you ask the target saying, hey, do you have port 8200 open? And if the target says, no, I don't have that open yet, get out of here, RST. However, if port 80 is open on the target, and you do like one of these, what they call stealthy scans, no, fin, or Xmas, you're not going to get an RST. Okay? So going back to answer Noodle Assassin's comment, yeah, here it is. Nmap minus A minus P0, 192.168.1.241. Go all the way down. Here it is. Port 1524, TCP, open, bind shell, root shell. Right there in the report. Right there in the results. Okay. Here it is. A key advantage to these scan types is that they can sneak through not certain non-stateful firewalls and packet filtering firewalls. Another advantage is that these scan types are a little bit more, here it is. This is for toe drill. The key advantage to these scan types is that they can sneak through certain non-stateful firewalls and packet filtering routers. Another advantage is that these scan types are a little bit more stealthy than even a sync scan. Don't count on this though. Most modern intrusion detection system products can be configured to detect them. Okay, so how do you actually run these stealthy scans? Here I am back in Kali again. Is sudo, you have to do sudo. These scans, null, fin, and Christmas tree scans, are also known as stealthy types of scans. These are called stealthy scans. Require sudo. Sudo nmap. Let's do a fin scan. SF minus SF. 192.168.1.241. This is a stealthy fin scan to see what ports are open at 192.168.1.241. Hit enter. Ooh, I forgot what my if my nmap has a password, boom. 977 closed ports. Hey, you did. Sudo nmap minus s capital F 192.168.1.241. Notice. Similar results. All the ports that are open, including 1524. And the state is open filtered. So what in the world is filtered means? Okay. This scan does not work on most units. Another downside is that they can't distinguish open ports from certain filtered ones, leaving you with response open filtered. What in the world is filtered? Port scanning basic, filtered. There are 6 states of ports can be open. Open, closed, filtered, unopened, open, filtered. Okay, so what filtered means? Filtered means Nmap cannot determine whether the port is open because packet filtering filters prevents the probe from reaching the port. The filtering could be done with a dedicated firewall, yada, yada, yada. Open filtered is Nmap places ports in this state when it is unable to determine whether a port is open or filtered. This occurs for scan types in which open ports give no response. Like no noisy response, like, hey, I'm an FTP server, come in. Like none of that. The lack of response could also mean that a packet filter dropped the probe or when response is elicited. So Nmap does not know for sure when the port is open or being filtered. The UDP, IP protocol, FFIN, no, FINs have class may classify ports this way. Interesting. Okay, so what about a Christmas tree scan? Sudo nmap minus s capital X 192.168.1.241. So what's going to happen here? Same results. Open filtered. And then you get your whole list of open ports, the port numbers, and the corresponding service. Now, the next step is let's take a look back again at what no, fin, and Christmas tree scans are. The no scan, we're not going to do a no scan because this one is kind of rudimentary. It's like, it does not send any TCP bits. The TCP flag header is 0. Fin scan and Christmas tree scans are interesting. Fin scan just only sends a scan, not a sync scan. It just sets the TCP fin bit. Christmas tree scan set the fin, push, and urge flags, lights the packet up like a Christmas tree. Now the reason why I have to show you this is because let's look under the hood on what the attacker, or what not the victim or the target will see by way of Wireshark. Let's look under the hood. So here I am. I'm going to close this. I'm going to actually minimize this. I'm going to open up Wireshark. That. For a Christmas tree, sudo nmap minus my low s capital X. That one. Alright, so I'm going to do a file open. And I'm going to go to my downloads. Oh yeah. And I want to show you a fin scan. What a victim or a target will see on their end. So this is a PCAP or fin scan. So the target that I'm gonna actually hit is 192.168.1.215 in this case. But take a look at what a fin scan looks like under the hood. The source at 192.168.1.218, that's the source. The destination is 192.168.1.215. From source port to destination port. Notice, you have a packet with a fin flag, and then the target will send an RST back. So in this case, I'm looking for port number 199 on target 192.168.1.215. Again, the target in this case is, in this PCAP, is 192.168.1.215. Port number 199. Hey, 192.168.1.215. Do you have one port in 199 open? By way of fin scan, RST gets sent back. Get out of here. No. Alright, do you have port number 3389 open? Target 192.168.1.215. RST. No. Get out of here. Alright, do you have 17 port, target 192.168.1.215? Do you have port number 1723 open? Get out of here, RST. How about port 1025? No, get out of here, RST. Hey, do you have any RST? Do you have port 80 open? Target 192.168.1.215. No response. You can make an assumption that you get no response, no RST, probably open. How about port 8080? Nope. RST. Hey, you have port number 22 open. Target 192.168.1.215. Do you have port 22? Are you running SSH? No response. No RST packet sent. You can make an inferencing something there. Interesting. So this is a sample fin packet. This is a fin packet set. This is what a fin scan looks like on Wireshark. You can see a lot of fin packets with RST ACK. So this is a fin scan. What about a Christmas tree scan? Same target. 192.168.1.215. It's a target. But notice the packet now, instead of having fin, it has fin, push, urge. Hey, 192.168.1.215. Do you have port 21 open? Nope. Fin, push, urge. Now get out of here, RST. Get out of here. Port 22. Do you have it open? Fin, I'm going to send you a Christmas tree packet. Fin, push, urge. No response from port 22. You can make an assumption that port 22 is open on target 192.168.1.215 by way of a Christmas tree scan. And you can see on a Christmas tree scan, you see packet with fin, push, and urge. Flag set. CRST. Hey, how about port 80? You got target 192.168.1.215. Do you actually have a web server open? Fin, push, urge. No response. No RST sent from port 80. So this is why I this is why I had to show Wireshark last week. Because someone asked here if you want to look under the hood, what does the attack, what does a victim, or what does the attacker actually, what does a victim or what does the target actually see? Here you go. Under the hood, this is what a victim or a target will see in Wireshark. They can see it all. Okay. Here in a Christmas tree, also in the fin scan, you don't see a lot of sync, ACK, and X. You don't see handshakes happening. You don't even see sync at all. Okay? So, one last thing, because we're going to be out of time, is what in the world is this 192.168.1.241 target that I'm using? You may be wondering, what in the world is this virtual machine at 192.168.1.241? What is this thing? Oh, by the way, before I close today, I just want to make a promise. I'm going to go to the root shell again at 192.168.1.241, sister 1524. RM minus RF star. Oh shit. Boom. Everything's gone. Oh, dead. It's dead. What happened if I try this again? Oh, it's dead. Everything's dead. RM minus RF did the job. But that's okay. I can live with that. What is this thing at 192.168.1.241? It's a deliberately vulnerable virtual machine called Metasploitable 2. You can download and use on your own computer or on your own network. So Metasploitable 2, also put out by Rapid7, is a test environment. It's a deliberately vulnerable virtual machine where you can hone and practice on your skills. Metasploitable 2 is a test environment that provides a secure platform to do penetration testing and security research. For a test environment, you need a Metasploit instance that can vulnerable target. So all you need to do, so what this is a really small, like by these days standards, only 800 megabytes, really small. It's a really small virtual machine. The login for the Metasploitable 2 is MSF admin, is the username, MSF admin as the password. Metasploitable 2, the exploitability guide. I mean, this is a deliberately vulnerable virtual machine for you to practice on. Here it is for our attacking system, Linux, preferably something like Kali Linux, which we've been using all day today. We will identify the open network services on this virtual machine using Nmap. Well, here we go. The following command line will scan all TCP ports on Metasploitable 2 instance. There you go. They use a little bit of different variety of Nmap, but we use Nmaps. Regular today. Nearly every one of these listening services provide a remote entry point into the system. They even talk about Unix basics, backdoors. There's one in, here it is. Interesting. So in this version of Metasploitable 2, it runs VSFTP, a popular server, but this particular version contains a backdoor. Let me bookmark this page. Yep. More unintentional backdoors. I think that was a 1541 one, was it? Weak password, whole bunch of weak passwords in the system. Vulnerable web services, all here. So again, what this deliberately virtual, this 192.168.1.241 target we've been using the whole time, yeah, it's a deliberately vulnerable virtual machine called Metasploitable, and it's put together by Rapid7, and it's free to download, and you can actually use it on either VMware or VirtualBox or any other virtualization platform. I still use this up to this day as a training ground and for training purposes. And with that, we are out of time. That is 5:47 right now. Yes. Yes, we are out of time. Okay. Hello. People are still here? So other than that, next week we'll talk still about Nmap. But this time we'll get into something sinister, which is denial of service. Next week we're going to do denial of service and Scappy. We're going to have a special guest next week, too. Okay? Next week, again, we're going to continue with Nmap, but we're going to actually now get into denial of service. See ya.